Hello, my name is Vanessa Walden, and I am a graduate student at the University of North Texas in the Information Science Department. This short video explains my thesis project on linked data, which is essentially putting library bibliographic metadata and other kinds of metadata too on the web. For most libraries, their bibliographic records are currently housed in a local database, encoded in a format that only libraries use. This acts as a data silo, creating a situation where a wealth of valuable information is unconnected to the wider world. Considering how much of our lives is enhanced by and even dependent upon the internet, this is an unsustainable situation for libraries. They would serve their patrons better and remain relevant in their lives if the Internet search engine was used as the preferred search tool, instead of forcing their users to navigate local databases with which they are unfamiliar. This project was inspired by Tim Berners-Lee's ideas of the semantic web and linked data, which is an extension of the World Wide Web. He called it a web of trust, where metadata would be created and authored in such a way that humans and machines could have confidence in the information that was found and the relationships that were established. By referencing data sets that are self-defining and encoded in a language that makes interoperability of the highest priority, machines can perform sophisticated tasks that are intuitive for humans. The Resource Description Framework, or RDF, data model is composed in a manner similar to a sentence, using triple statements, where a person, thing, or concept, which is the subject, is described in terms of a type of relationship, the predicate, to a person, thing, or object, the object. Person, thing, or concept, the object. When these statements are strung together, they create a record that describes a resource. Many metadata librarians have published papers applying these ideas to library metadata and make it clear that libraries need to make this conceptual shift with regard to open and accessible bibliographic data. They build on the ideas of the semantic web and linked data and connect them to library-specific bibliographic concepts, such as the functional requirement for bibliographic records and resource description and access, which is slated to be a replacement for MARC. This project helps further that conceptual shift by using a small special library, the San Francisco School of Needlework and Design, as a test case and addresses the practical implications of a linked data project. There is a significant body of literature on library linked data, using large data sets and digital collections. But this one narrows the scope and encourages participation in the linked data movement for small and specialized libraries. The case study will attempt to show that a linked data project can be implemented in a small library setting with limited funding and technical knowledge, and that publishing linked data records can increase the visibility of resources to those conducting searches on the web. It is about gathering practical information on how a small library can envision and execute a linked data project. Understanding what technical knowledge is necessary to begin a linked data project is a key piece of information to have before starting. Any institution attempting to replicate what was done here will also need to know about any free or low-cost tools that are available to help assist with implementation. It was also important to note how much funding was required and how much time it took to implement a small-scope linked data project. All of this data ultimately contributes to answering the question of whether or not a linked data project is beyond the scope of what a small library can achieve. The methodology was primarily qualitative in nature. It started with obtaining permission and authorization from the San Francisco School of Needlework and Design, and to use their library collection as a test case and publish pages on their website. Bibliographic records were searched and downloaded from the OCLC database, and 5 of these records were chosen to encode in RDF XML format. A web page in RDFA and HTML format was created and referenced the RDF XML files. The web page and RDF XML files were published on the San Francisco School of Needlework and Design's website. 3 popular search engines, Google, Yahoo, and Bing, were used to test discoverability on the World Wide Web. Throughout the implementation process, data and observations on the technical aspects, funding required, and time spent at each of the various phases was recorded. The findings fell into one of these 3 categories: technical knowledge and tools, funding, and time. It was found that a significant body of library cataloging knowledge was required, including familiarity with library bibliographic records encoded in MARC, and experience navigating the OCLC database. On the technical side, it was necessary to have a firm understanding of the theoretical and conceptual frameworks of the semantic web, linked data, and the basics of search engine optimization. In order to execute the project, knowledge and experience with various computer languages and formats was also a necessity, such as RDF, JSON, XML, CSV, HTML, and CSS. While the philosophical concepts can be difficult to grasp at first, there are many practical tools available to help with the execution of a linked data project, especially from the World Wide Web Consortium, otherwise known as the W3C. Other helpful tools included the book Linked Data: Evolving the Web into a Global Data Space by Heath and Beiser, and training tools from the web, like Codecademy and lynda.com. The funding required was very minimal. A small fee was paid to a contracted web administrator for assistance with authorization to publish the web pages. The time it took to complete the project was also very reasonable, totaling about 80 hours of work over the course of 4 weeks. After collating the data, it became apparent that at least starting a linked data project was achievable by a small specialized library with limited staffing and funding. The investment in time and money was reasonable, especially since the majority of the project was completed by a volunteer. Another similar-sized institution can expect the testing phase of a project such as this one to be relatively short, as long as the technical expertise and funding considerations are in place ahead of implementation. Overcoming the obstacles of the technical expertise will be the most challenging aspect for a small library. Adding complexity, such as interfacing with an existing library catalog database or publishing a large number of records, would increase the investment of resources required. This project addressed linked data adoption in a very specific environment, providing research for similar libraries to draw upon. The most important consideration is identifying the resources and technical knowledge available to a small institution. A similar-sized institution should be prepared to make investments in time and training to overcome any obstacles if staff, paid or volunteer, do not already possess the necessary skills. Attaining these skills is not impossible with the right tools and advice. it is recommended that the institution consult with other library professionals, system administrators, and web administrators with expertise in bibliographic metadata and computer science, and extensively research concepts and examples on the World Wide Web. Unfortunately, this project did not result in a web page that was retrieved by one of the search engines, but it may be possible with further website and coding redesign. My study into alternative coding and methods will continue until this most important deliverable is achieved. There is much room for further study on which search engine optimization enhancements create a positive impact on discoverability, and once achieved, analyzing how the website traffic and business-to-customer interactions and patterns change after publishing the link data. There is also a need for more studies like this one in other library environments, including small public and school libraries. My hope is that this paper encourages more participation by small libraries in the linked data movement. As it stands now, many of the ongoing library-driven linked data projects involve large data sets, but the semantic web and the realization of linked data will be built upon both large and small data sets coming together and connecting to each other in a meaningful way.